Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into a fascinating paper from Arxivore, Tiny Pointers. It's all about revolutionizing data structures. You know, the fundamental building blocks of how we organize and access information in computers. Exciting stuff!
Yeah, I saw this one too. So what's the big idea behind these tiny pointers? Are we talking about, saving a few bytes here and there, or something more significant?
Oh, it's way more significant than a few bytes. The core concept is replacing traditional, relatively large pointers, which use log n bits, with much smaller, tiny pointers, using O log n bits. Think of it as a massive space-saving technique.
O log n to O log n. That's a pretty substantial reduction, especially for large datasets. But what's the catch? There's always a trade-off, right?
Right, there's a constant factor, time overhead. But the authors argue that, in many applications, the space savings far outweigh this minor time penalty. They've developed optimal constructions for both fixed size and variable size tiny pointers.
Fixed size and variable size? Explain that.
Sure. Fixed size means all tiny pointers are the same size, while variable size allows for some pointers to be larger than others, as long as the average size remains small. This flexibility is key to optimizing space usage. For a load factor of 1 to 1k, the optimal fixed-size tiny pointer is theta, log n plus log k bits, while the variable size case is a much more compact, theta, log k, expected bits.
Wow, those are some impressive formulas. So, what kind of problems are they applying this to?
They've applied tiny pointers to 5 classic data structure problems: data retrieval, succinct dynamic binary search trees, space-efficient stable dictionaries, space-efficient dictionaries with variable size keys, and the internal memory stash problem. In each case, they've taken existing, space-inefficient solutions and made them significantly more space-efficient. Essentially, they're getting space efficiency for free.
That's remarkable. I'm curious, though, did they have to tackle any other interesting problems while developing these tiny pointers?
Absolutely. Their work involved revisiting classic balls and bins problems. These are fundamental problems in computer science, and their new results in this area might be of independent interest to researchers in that field. It's a really comprehensive paper.
It sounds like a game changer for data structure design. This could have huge implications for memory-constrained systems, right? Embedded systems, mobile devices.
Exactly. Anywhere where space is at a premium, tiny pointers could be a real breakthrough. This is a significant contribution to the field.
I agree. This paper is definitely worth a closer look for anyone working with data structures. Thanks for summarizing it for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll see you next time. Goodbye.
Bye-bye.